mention something. Oh, okay, that's fine. And we want to make sure it is actually recording. Yep. All right. So the first thing we want to do is to go over the questions. There was one question that I made a mistake that turned it into a very trivial question. Most of you probably still remember that one. I hope nobody second guessed, himself or herself enough to say that no, it cannot be this easy. Let me just do it the long way. No, there is no long way.
I second guessed myself.
You did?
Yes.
It's like in, out, done.
Yep. Not even in. It's just test, out, done.
I know, but like assign variables and out.
Yep, pretty much. Okay, so we'll go over those questions first. Here you go. So I hope you guys like that question.
Well, I really don't. 3 points.
Yep, pretty much. Just being here. Let's try this with a Zernal. Yeah, this is kind of like this is an interesting software. Because it looks just like a PDF reader, except I can type, I can write, I can highlight, on this, sheet here, so that when I save it, I can save it as a journal file too, a Zernal, Xournal. And they have a port to Microsoft Windows too. So you can actually open up the file in Microsoft Windows and be able to see exactly what you see in the class. So in a way, it's nice, when we have, a PDF type of document to annotate. And let's see if we can zoom in just a little bit, just a tad. There we go. That may be a little too much already, because I cannot see both the code and the trace, just barely. That's good. Okay, so this one, there are certain variants of this one too. Let's see. No, this one, there are no variants because it depends on your own student ID. So you have to kind of type in your student ID here first, and then you run the program. Okay. Any questions about this one so far? Do you guys want me to trace it? Okay, let's go ahead and do it. So in my case, we'll just put in, no, I can't do this.
There's characters out there at the top.
Yeah, but that's going to be very cumbersome as well, because I have to do it like this. For each digit, I have to type. So that may be less efficient than if I just use a spreadsheet to do it. I just go. This would be good for a science class, because with a science class, when you have to draw pictures on the fly or annotate pictures, it'll be much more useful. But since we are tracing algorithms, it's all table-based, this would be a better way to do it. Oh, I cannot resize from that side. I can only do it from this side. Here we go. And we'll save the file first. Oh, I haven't changed anything. It doesn't let me save it yet. Okay. So I have to copy the headers. I think the test in general was not very hard. There were no tricky questions. Typically, with a trace type of exam, it's really hard to ask anything that's tricky, because all you have to do is to follow the algorithm, and that's all you have to do. Okay, array A has 1, 2, 3, 4, 5, 6, and 7. I might need to resize some of these later, but I'll do it later. Save the file first before we forget. There we go. And the initial state is everything is unknown. And the array A is supposed to have digits of your student ID. So I'm just going to use a fake one here. So I'm going to use 1, 7, 2, 3, 5, 3, 6, 2, 0, and 1 again, 2.
Hey, that's mine.
Sure. What are the chances, right? All right. So that's our precondition, and you guys need to write the precondition too, because I need to make sure that people understand what the precondition is. And then we start with line 1. The boring stuff, would be the first 4 lines or so. Got 0.
That's free points. Right?
Okay. Line 2 puts a 0 here. Line 3 puts a 0 here. And line 4 puts a 0 here. The actual conditions would change a little bit depending on which version of the test you get, but they're all about the same. Okay, in fact, in this one, there's only one algorithm because everything else depends on your student ID, so there's only one version of the logic. All right. On line 5, we have to evaluate the condition I is less than bar A bar minus 1. What is bar A bar?
7.
7. 7 minus 1 is 6. I has a value of 0. 0 is less than 6 is true. So we go to line 6. So now you just have to evaluate, and find out which condition is true. So in this case, we have A bracket I is less than A bracket I plus 1, close bracket. And we want to find out whether that is true or not. The only part I think you have to be careful about is the plus 1 is inside the square bracket and not outside of the square bracket. That changes everything, because if it is inside the square bracket, I am changing the index of the item that I want to access. If it's outside of the square bracket, I'm adding 1 to the value of A bracket I. So that's the only thing that you have to watch out for. In this case, I is 0 at this point, so A bracket I is A bracket 0. It's comparing column G to column H. A bracket 0 is 1, A bracket 1 is 7. 1 is less than 7 is true. And so we go to line 7. Line 7 is adding 1 to X. X goes from 0 to 1. Then we get out of the entire conditional statement. We go to line 13. Line 13 is going to add 2 to I. Now this is the only part that I will even call semi-tricky, is that I'm not adding 1 to I, I'm adding 2 to I. Okay, did anyone add 1 to I?
I did, but I saw it after I finished the whole thing. So I erased.
Oh, then you don't have to erase everything. You just have to block out some of your traces.
No, I do.
Oh, you do, because it does change the other the counters.
And also being a perfectionist.
Okay. That's the only part that I would call even semi-tricky. I is now 2. 2 is still less than 6. So the condition is true. We go back to line 6. Line 6 is comparing A bracket I, which is now 2, to A bracket I plus 1, which is 3. So we are comparing column I to column J. 3 is less than 6 is true. So we go to line 7. We add 1 to X. X goes from 1 to 2. We get out of the conditional statement. We end up on line 13. We add 2 to I again. I goes from 2 to 4. And then we go to line 7. Nope, excuse me, line 5, which is the beginning of the loop. 4 is still less than 6. So the condition is true. We go to line 6 again. And this time we compare A bracket I, which is A bracket 4, to A bracket I plus 1, which is 5. In other words, we are comparing column K to column L. 2 is less than 0 is false. That means we have to test the second condition on line 8. On line 8, we are checking whether the first one is greater than the second one. And in this case, that is true. We go to line 9. We add 1 to Y. Y goes from 0 to 1. And let's see, we can do this here. Then we can just scroll it off. After line 9, we get out of the conditional statement. We end up on line 13. Line 13 is going to add 2 to I. I goes from 4 to 6. Then we go back to line 5 again. 5 is less, 6 is less than 6 is false. So we never have a chance to access an element out of the range of the array. So since that is false, we get out of the loop, which means we get to post, and that's the end of it. Any questions about this trace? Your trace will be different depending on your actual student ID. If you have a student ID of 1, 2, 3, 4, 5, 6, 7, you will only exercise a part of the logic. Yep.
Would it be possible to access an element that is not listed there?
Not in this algorithm, because the condition of the loop on line 5 guarantees that by the time you get into the body of the loop, not only a bracket I is a valid element, a bracket I plus 1 is also guaranteed to be a valid element. So it will never access an element out of range. Okay. Any questions about this one? Yep.
That's what you were talking about, Perl and C+ or whatever. If
No, because in this case, it doesn't matter what programming language you use. In this case, it will still do the correct thing, because I never attempted to access an element out of range.
okay,
So what a programming language would do when you do access an element out of range does not even matter, because I never did that.
okay,
The index, you can see, if you look at I, the range of I goes from 0 to 2, 2 to 4, 4 to 6. But by the time it gets to 6, I get out of the loop before I have a chance to use I plus 1 as an index into the array. So it should never access an element out of range in this case. Is that good? Okay. We make sure we save this one, and then we move on to the next one. So I'm not going to save the Zerno version. The next one is question number 2, and we'll just open one version of that. All right. This one looks kind of funny, and in all variants, there are 5 variants of this. In all variants, it will actually exercise and go through every single element in the array, and then it will go back to the beginning. So let's go ahead and trace this one. And once again, I think using a spreadsheet is more efficient. So we'll go use a spreadsheet. Has anyone tried out this free mind program? No. It's a program that lets you draw bubble diagrams. So when you are, let's say you're writing an English essay and you want to organize your thoughts, it's a way to do that sort of thing. It's actually pretty cool. I think there's a port to Windows as well. It's a Java program, so it should run on any platform. Yep.
is that in LibreOffice?
No, this is it's a standalone program. FreeMind is a standalone program.
Oh, okay.
It's written in Java, so it should run in any platform. I'm using the wrong control. That's fine. Okay. So once again, we have comments, line number I, and in this case, A has 5 elements. So A bracket 0, 1, 2, 3, 4. I'm just going to work my way back. 13, 7, 57. That's unknown. That's pre. So the precondition is already given to you. You don't even have to worry about it. It's already done. There we go. All right. So let's take a look at the algorithm. Save the file. This time I will say it's Q2A because there are 5 variants of this question. This will point it to exactly the correct one. All right, line 1 doesn't do anything really interesting. All it does is to initialize I to 0. And then line 2, we don't track because line 2 is just a marker to indicate the beginning of a post-checking loop. So the next line to track is line 3. Line 3 is kind of a difficult line to track because it is one single line. I'm not breaking it up into multiple lines, so you do have to do the calculation, on a separate piece of paper or next to, the table. But it is not really complicated math here. I is 0, so we have 0 plus a bracket I. Since I is 0, a bracket I is 57. We have to mod it with bar a bar. What is bar a bar?
5.
Bar a bar is 5 because there are 5 elements in the array. What is 57 mod 5?
2.
It's 2 because mod is the remainder of the division. 57 divided by 5 has a remainder of 2. Okay? I think in all variants, the divisor are fairly easy to calculate. I did not give anyone like 17 as a divisor or anything that would remotely require a calculator. So in this case, it is 2. So that means the parentheses will just be 0 plus 2. 0 plus 57, which is 57. 57 mod 5 is 2, and then that goes back into I. So I now has a value of 2. Is that okay?
Mm-hmm.
All right, so now we go to line 4. Line 4 is going to evaluate the exit condition. I equals 0 is the exit condition. It is false. So what should I do next? If the exit condition is false,
Line 3.
I have to go back. Okay? Because when the exit condition is true, that's when we get out of a loop, a post-checking loop. So we go back to line 3, and this time I is 2, and then a bracket I, which is a bracket 2, has a value of 7. 2 plus 7 is 9, and 9 mod 5 is
4.
4, and then we put the 4 back into I, so now it is 4. We go back to line 4. I equals 0 is false. We have to go back to line 3 again. So this time, inside the parentheses, we have 4 plus a bracket 4 close parentheses. A bracket 4 has a value of 17. 4 plus 17 is 21, and 21 mod 5 is 1. Very good. Then we go to line 4. Condition is still false. Then we go back to line 3. This time it becomes 1 plus a bracket 1. A bracket 1 has a value of 47. 1 plus 47 is 48. 48 mod 5 is 3. And we go to line 4 again. I equals 0 is false again. We go back to line 3. It becomes 3 plus a bracket 3. A bracket 3 has a value of 37. 3 plus 37 is 40. 40 mod 5 is 0. Then we go back to line 4. I gets 0 is true. And we're done. Okay? And in all variants, it will go through all the numbers, except in different orders. Okay? I think in one variant, instead of adding, instead of 57 and whatnot, they all end up with 3s, like 13, 3, 33, and so on. And in that case, it will be 0, 3, and then it wraps around to, let's see, 3 plus 3 is 6, 6 mod 5 is 1, 4, and then the last one is 3 again, and then it will go back to 0. But they all they will all exercise all 5 possible values, and then go back to 0 in the end. Any questions about this one?
I guess he asked the same question a while ago. If that turned out to be a bracket I out of that sequence for some reason, if I would happen to be 5.
Say again?
If I happen to be, I guess it wouldn't.
I cannot possibly be
not
5 because
yeah.
we are modding it with 5.
Okay.
In other words, the remainder of something divided by 5 has to be 0 to 4, because if it were 5, you would have added 1 to the quotient instead.
Well, let's say in bad code, if it was some reason it can access, or is it's saying reference A bracket I, which is I is outside of the domain of A. What would happen then? It would just crash, or would
Then it
not?
depends on what programming language you're using.
Oh, okay.
But in a trace like this, you should indicate that it's accessing an array out of range and should stop just right there. Yep. Any other questions about this one? Yep.
In other variants, did you put the parentheses in different areas?
No, the parentheses are always like this. I changed this part. I changed the initial value of A bracket I, the entire array A. We can take a look.
So the other variants on the code is the same on each one, right?
Yes, the code is the same. It's just that array A has different initial values. We can actually go take a look, just so that you guys can see the other variants. So this one ends with 3s. If it ends with 3s, then it will be 0, 3, 1, and then 4, and then back to 3, with it back to 1. No, it has to end at some point. Okay, let's see. I'm just doing the calculation quickly in my head. Okay, so it will go from 0 to 3, and then 3 plus 3 is 6, 6 mod 5 is 1, 1 plus 3 is 4, 4 mod 5 is 4, and then 4 plus 3 is 7, 7 mod, it goes to 2, and then gets back to 0. So this will be the sequence of I in the case when we have 13, 3, 23, 53, and 43. Now, the 10 does not matter. I can have 103 and it would not matter anyway, because if you look at 103 and you look at 13 or 3 itself, they all mod 5 to exactly the same result. And that's why it does not even matter. So that's one variant. And we can look at the other 2 variants. The other 3. This one is the easy one. If it ends with 1, then we go from 0 to 1 to 2 to 3 to 4 and then back to 0. So that's one of the easiest one. But whoever gets this one still has to go through the mod operation. Okay, so from that perspective, it's not actually any easier than the other ones. Let's see. This one is 4. 4 is the same as -1. Because when you do calculations using mod 5, adding 4 is the same as subtracting 1. So in this case, it will go from 0 to 4, and then 4 plus 5 is 9. 9 mod 5 is 4. No, that something is not right.
4 plus 4.
No, 4 plus 4 is 8. 8 mod 5 is 3. 3 plus 4 is 7. 7 mod 5 is 2. 2 plus 5 is 7. No, 2 plus 4 is 6. 6 mod 5 is 1. And then 1 plus 4 is 5. 5 mod 5 is 0. So that would be the sequence for this case. And the last one is case E. This one has a little mixture. Does it matter? Does not matter at all. Why doesn't it matter? Because if you think about it, any number that ends, any decimal number that ends with 7 or 2 will still give you the same mod result when you are modding it with 5.
Plus 2.
So it makes no difference. This is the same case as when you just have 2, 22, 32, 102, and so on. So in this case, it will go from 0 to 2. 2 plus 2 is 4. 4 mod 5 is 4. 4 plus 2 is 6. 6 mod 5 is 1. 1 plus 2 is 3. 3 mod 5 is 3. 3 plus 2 is 5. 5 mod 5 is 0. So that's the sequence when we're adding by 2. This is the sequence when we're adding by 4. This is the sequence when we're adding by 3. Any questions about this? No questions? If you are going to tighten the lug nuts of your wheels, which one would you use? It's always helpful to relate everything that we do to real life.
2. Probably 2.
2 would work. 4 will work too. You just don't want to use 1. Or 4 you don't want to use either. This would not be a good sequence for tightening your lug nuts. Because you're supposed to go in a star shape, and this will give you a star shape, this will give you a star shape as well. So who would have thought, this has something to do with changing tires? All right. Any questions about number 2? And we're going to move on to the trivial number 3. Number 3 is the one that is really easy. This is the one. Is that the one? No, I think it's the last one. The fourth one. It was too easy.
Never.
Never. It's so easy, I have to do something about the final exam to make up for it.
Find the easier one.
Comments, line number N, I, K, and then array A. And in this case, array A comes with different values depending on which version you get. So I'll just work with this particular one. 3, 2, 3, 5, 7. And then we have array B, which is 0, 1, 2, 3. These are unknowns. So we just have to look at the algorithm. We cannot trace. Here we go. All right. So the precondition is pretty much given to you. Everything is unknown except for contents in the 2 arrays. Array B is still unknown. Array A has known values. Line 1 puts 0 into K. Line 2 puts 0 into I. And line 3 compares N, or N has to start with some known value then. N starts with 45 in this case. Okay, so N starts with 45. So on line 3, we have to evaluate whether N is greater than 1 or not. N, which now has a value of 45, is greater than 1. Is true. Then we move on to line 4. Line 4 is an inner loop. Okay, so this one tests whether people understand how to handle a loop inside a loop. But this is not the first time we have seen a loop inside a loop. We had that in the previous exam already. N mod A bracket I is what? N is 45. And what is A bracket I?
2.
Well, I has a value of 0, so A bracket I has a value of 2. That is correct. 45 mod 2 is 1, and 1 equals 0 is false. Okay, very good. So that means there's no need to go into line 5, 6, or 7. We go straight to line 9. Okay, and I won't even call this tricky. You just have to see whether there's any other code after the end of the inner loop. On line 5, we just add 1 to I. So I goes from 0 to 1. We go back to the beginning of the outer loop, which is on line 3. N has not changed. N is greater than 1. It's still true. So now we move on to line 4. Line 4 is doing N mod A bracket I, but I is 1 in this case. A bracket 1 has a value of 3. 45 mod 3 is
0.
In fact, 0. So this is true in this case. We have to go to line 5. Line 5 is going to copy A bracket I to B bracket K. A bracket I has a value of 3, we just access that. B bracket K is column J because K has a value of 0. So we are accessing B bracket 0. Column J in this case is now initialized to a value of 3. We move on to line 6. We add 1 to K. K goes from 0 to 1. We go to line 7. Line 7 is calculating n divided by A bracket I. Do we have to worry about, are we only taking the quotient or are we taking the actual result of the division?
The result.
Does it make any difference? It makes no difference because we know A bracket I is a factor of n in this case. So it has to be an integer. It cannot be a fractional number. Okay, it cannot be a proper fraction, I should say. So in this case, it's 45 divided by 3, which gives you 15. And we put 15 back into n. And then we go to line 4 again. This is the inner loop. Remember, we are ending the inner loop. We have to go back to line 4 again. So n this time is 15. 15 mod 3, because we haven't changed anything about I, so we are still accessing A bracket 1. And that is also 0, because 15 is divisible by 3. So that it turns out to be true again. We go to line 5. Line 5 is going to copy A bracket I to B bracket K, but because K is now 1, we have to put the 3 into B bracket 1 in this case. You guys can see what this algorithm is actually doing. It's factoring. It's trying to find the factors of n and put all the factors into its own array. So on line 6, we add 1 to K, so we'll be ready for the next one. Yep.
Okay, would it be possible to have an open-ended B array if you were doing like massive numbers?
Well, in this case, we are not even using up the entire array B, but it is correct that sometimes you can run out of room, because B has a fixed size. Unless you're dealing with Perl or some other interpretive language, then you can expand the array on the fly.
Is that, okay, we covered that a little bit, it seems like. Is that why it's like that in those languages? Were they designed to do that?
They're designed to handle stuff that are different from what C was designed to do. And that's why in most scripting languages, the arrays are what we call elastic. It can shrink and expand, as you want it.
Oh, wow.
Yep. So line 7 is going to store the result of 15 divided by 3. 15 divided by 3 is 5. And then we go back to the beginning again on line 4. N is now 5. A bracket I is 3. 5 mod 3 is 2. 2 equals 0 is false. We get out of here. We go to line 9. We add 1 to I. I goes from 1 to 2. We then go back to the beginning of the outer loop, which is line 3. You can see that once you go through a few iterations, the rest can be somewhat boring. We go back to line 3, n, which has a value of 5 in this case. 5 is greater than 1 is true. So we go to line 4. Line 4 is asking n is 5. A bracket I is what? I has a value of 2. A bracket 2 has a value of 5. 5 mod 5 is 0. That means we have to go to line 5. Line 5 is going to copy the 5 to B bracket 2 because K has a value of 2 at this point. So we'll copy 5 to column L. Then we move on to line 6. We add 1 to K. K goes from 2 to 3. Then we go to line 7. N is 5. A bracket I is also 5. 5 divided by 5 is 1. We store that back into n. Then we go back to the beginning of the inner loop. N is 1. A bracket I is 5. 1 mod 5 is 1. 1 equals to 0 is false. We get out of the inner loop. We go to line 9. We add 1 to I. I goes from 2 to 3. Then we go back to line 3 again. N is 1. 1 is greater than 1 is false. And we're done. So this is a factoring program. And the nice part about this factoring program is once it identifies a factor of a number, it will keep testing that number until it is no longer has that factor. Depending on the variance that you get, the main part of the logic does not change. I think I made sure that there are only two factors, and then one would repeat twice. So it may be 2, 2, 5, maybe 3, 3, 5, 5, or something like that. So the variant is only based on which number is repeating itself, and but it does not really change the overall length of the trace. Any questions about this one? No questions? Are you guys starting to see how the mod operator is useful? Every calculation that you do in a real program is a mod operation. Let me just kind of explain that a little bit. I think I explained that earlier in this class already, but it doesn't hurt to remind you guys about the mod operation. Remember that every integer that you store needs to have a certain fixed number of bits. Okay, it can be, in the early days we have 8-bit numbers, which can only represent numbers unsigned from 0 to 255. Signed, it is from -128 to +127, which is not a whole lot of range. Then we upgrade to 16-bit integers. 16-bit integers can roughly represent -16,000 to about -32,000 to +32,000 signed. That's still not a whole lot of numbers. Okay, so let's just take 16-bit integers into consideration. 16-bit integers. Now, the way you look at a 16-bit integer in terms of calculations like adding, subtracting, dividing, and so on and so forth, is each integer is really kind of like a big wheel. Okay, on the wheel you have these numbers, 0, 1, 2, and then on the other side you can, if you want to, look at it as -2 in this case to the power of 15. Yeah, that's it. Okay. This is the largest, excuse me, I was wrong. This is actually -1, -2, and so on. And then these two sides will meet because it's a wheel. It's not a number line, it is actually a number circle. So at the end, they will meet. The negative numbers will keep going more and more negative, and the most negative number you can store with a 16-bit number is 2 to the power of 15. Which is roughly 32,000.
-1.
No, not -1, not the negative side. The positive side or the non-negative side, which starts with 0, will go to 0, 1, 2, and then it goes all the way to 2 to the power of 15 minus 1. The -1 is only here to account for 0, which takes up one slot on the wheel. Now, why does this has anything to do with mod, MOD, the modulus operation? What if you add two numbers that is beyond the representation of this number?
You mod it, and then like you get the mod like we were just doing real fast without having to calculate the whole thing every time or something like that?
Something like that. What is happening when you're adding to this number? When I said each number is a wheel, I was actually somewhat lying, because it's not just the wheel, but you also have just like Wheel of Fortune, you have a little thing that indicates its current value. Okay? So when you're adding numbers, you're basically assuming this marker does not move. When you're adding, you're turning the wheel this way. You're turning it counterclockwise. When you're subtracting numbers, you're turning it clockwise. And the constant you're adding or subtracting is only determining how many slots to rotate in whatever direction you choose to rotate. So what if you want to rotate it more than 65,536 slots, which is the total number of slots here? It just rotates back to the numbers that is already on the wheel. And that's why it has to do with modulus or mod, because every calculation you do with 16-bit integers is basically, let's say A is a 16-bit number, representing a 16-bit value, and B is also a 16-bit integer representing another 16-bit value. If the sum C is something more than what a 16-bit number can represent, what is going to happen? The program is not going to crash. In Visual Basic, it does. Okay, in Visual Basic, it always makes sure that the result can be stored into something. But in this case, if you're doing in C, it doesn't check anything. So basically, you have a hidden mod operation here. In this case, it's mod 2 to the power of 16. Because it's a wheel. Okay? If you look at the examples that we have been doing, let's say the previous one, you basically have a much smaller wheel with only 5 numbers. You have 0, 1, 2, 3, 4. Every time you add something to it, you're just rotating it in one direction. And the marker is always pointing to a particular value. So if you rotate, let's say if you add 1 to, okay, right now, okay, this is the value of 4, and this is 0, 1, 2, 3, 4. So I have 1 too many marks. Let me just erase this one. Okay. So right now, the value of the variable is 4. What happens when you say add 2 to 4? You're rotating it twice, 2 slots. Those 2 slots over will be 3 and then a 2. Is that right?
No, the other way.
The other way, sorry. So 2 slots, this way, adding 2 is rotating it counterclockwise. So in that case, it will be 0 and 1. So 4 plus 2 suddenly becomes 1 and not 6. But that's because everything is done with a mod 5 implied. And with 16-bit integers, everything has a mod 2 to the power of 16 built into it. With 32-bit number, it has a built-in mod 2 to the power of 32. Okay. Well, just little things that I think you should know, because we are on the topic of mod, and how everything is kind of cyclic because it is a big circle. All right. So we're done with number 3. Now back to the trivial one. Basically, free points. Free points. Cannot be more free than this.
Best things in life are free.
It's freer than open source software. Okay, I think in this case, all variants have the same thing. Is that question number 4? Except this one does have something to do, doesn't it?
No.
No, it does not. No. Well, I don't think I need to trace this one. Okay, let's just take a look at the initial, the first line, the precondition. The precondition in all cases, okay, the only difference between the versions would be the initial value of n and array A. But all variants have n initialized to a non-zero value, and that's all that counts. Because you have I getting 0, okay, that's fine. We change column I to 0, and then on line 2, the first thing it checks is n equals 0. Oh, 45 does not equal to 0. And if you read the instructions carefully, I also want you to use short-circuited evaluation, which means I'm done. You still have to indicate, you have to finish it up, okay? You have to tie up the loose ends. So you have to say, the condition n equals 0 is false, and then that will be enough reason for you to get out of the loop, to post, and you're done. Then you ask tech, is it really that simple? And then tech will tell you, I cannot tell you that. You just have to follow the code. Yep.
Like 50 times.
If you made a mistake at the beginning, just like instead of and, you switched it around to or for some reason.
You have to change a few things around to make it actually go through an iteration. Because if you switch the order of these two,
Of and to or for some reason. I don't know why. So everything messed up, and I did this whole long
You will probably get some points taken off. I'm afraid it's going to be a little bit hefty because because this is so trivial, I cannot really have a lot of partial credit anymore. Do you understand what I mean? So I can still see that you understand how to deal with a loop, but the evaluation of the condition of the loop becomes a very significant portion of the grade. So you'll get partial credit for that. I'm not going to take off all the points. Yep.
Okay, now this is a crazy question. I isn't defined, so how could it be less than bar B bar anyway?
Line one.
Because line one initializes it.
That's right. We just haven't wrote it yet. All right.
Mm-hmm. Any questions about this one? No questions? Okay. But I think this is a pretty easy question now. I mean, even without that mistake, even if I had said, n is greater than 0, which is the original intention, it would still not be too difficult. I mean, this is a fairly simple one to evaluate. All right. Any questions about the exam? You probably have a rough idea of your score already, since we talked about it. No? No idea?
It's not official.
Well, first of all, I have to scan the whole thing, and then I would grade it. I would have to do the same thing as last time, make a big spreadsheet of all the point values and who gets how many points where. So Thursday would be a push, probably next Tuesday or so. But we have already passed the last day to drop without. We have gone past the last day to drop, haven't we? Yeah. So it doesn't matter anyway.
In or out?
No, I will try to grade it, as soon as possible. So. All right. So that's the exam. We now go back to our main topic. What was the last thing that we talked about? I think we were talking about passing by reference, parameters, passing by reference. So let's go back to passing by reference and just, go with the book. Oh, the homework. Okay, sure. The homework is funky subroutine. Go. We have the code here. Then we look at the trace.
References. So
Sheet 2.
inside and outside.
All right. How should I set up, for the quote unquote the global variables? How many columns should I use for global variables?
There are none.
There is none. All right. There's none because if you look at, I shouldn't put the 0 here. There's none because if you look at the reference of variables of any kind, they're all inside funky. And funky has y and also x. But we already know that y is a local variable, which means it's not a global. And x is a bival parameter, which means it's also not a global. So we don't really have any global variables in this case. All right, let's trace this one. So the precondition, there's really nothing to say because we don't have any variables existing at this point.
Do we still have to do a pre?
Yeah, I would still do it, just so that we know that there's nothing to state, when we get to the first line of the execution. It's not a big deal. I'm not going to take any points off if you miss that. But I would still make I would make an effort to, clearly indicate that there's nothing to say as a precondition. Okay, line 9 is our first line, which is the only line outside the definition of a subroutine, and it's an invoke statement. So after 2 weeks, do you still remember what invoke does? There are several things it has to do. Okay, there are certain things that is optional. The things that it has to do is to remember when the subroutine is done, where am I supposed to go back to? So that means we have to remember the return line number. In this case, the line that is logically following line 9 is post. But in this case, we also have some optional stuff to do because the subroutine has a parameter x and a local variable y. So we have to allocate columns for those two on the fly as we execute the invoke statement. The local variable y is the easy one to deal with because all local variables start with an unknown value. So that we'll put a question mark there. The initial value of a by-val parameter is
Given in the
is specified by the invoke statement. So in this case, it is the line 9, the invoke statement. It specifies that 2 is the initial value of x. Other than this part, a local variable and a by-val parameter actually behaves pretty much the same way. Any questions? Okay. So after we set up all the columns, we can continue execution in the subroutine starting on the first line of code, which is line 4 in this case. Line 4 is going to store x minus 1 into y. X has a value of 2, 2 minus 1 is 1, so y gets a value of 1. We go to line 5, we evaluate x is greater than 0, x is 2, 2 is greater than 0 is true. Then we go to line 6, which is a recursive call because it is calling the subroutine that we are already in. But that's okay, we know that we should not panic. Okay, we know that it doesn't matter where you're calling a subroutine or where you're invoking a subroutine, it still behaves exactly the same way. We go through exactly the same mechanism to do the same thing. So in this case, we already know we have a return line number, we have x, and then we have y. Y is a local variable, so it always ends with a question mark. X is specified by the invoke statement. In this case, it is line 6. We are using the value of y to specify the value of x. The y is referring to column E, which has a value of 1. So x as a parameter starts with a value of 1. The return line number in this case is kind of tricky. It is actually line 8, because line 8 is the line that is logically following line 6. When you're done with line 6, we don't track line 7. Now, if someone puts in line 7 here, I'm not going to take any points off, but I do use this opportunity to tell you that in the final exam, you have to remember that you have to put in the line number of the line that is logically following the invoke statement, not just the line number next to it. Okay. And that's how we set up the next columns. Then where do we go? We go back to the subroutine, starting from the beginning again. Now that part is also important because when I do not emphasize that fact, some people would actually it will continue execution somewhere else in a subroutine. But every time you invoke, you have to start from the beginning. So line 4 is going to evaluate x minus 1, which in this case is going to be 0, and store that into y. So y ends up with a value of 0 in this case. We go to line 5. X is greater than 0 is true because x still has a value of 1. Yep.
I thought only by reference could grab out of other columns.
Correct. Only passing by reference has the ability to refer to another column. And this subroutine has no passing by reference. This is passing by value, which is the same as making a copy of something.
But reference means it could pass back, and this won't. That's what you're saying.
Passing by reference is a wormhole. So every time you access the parameter, it is the same as accessing what it's referring to. Passing by value is a copy of whatever you're passing, so it doesn't actually go back to the source, the origin of that value. Okay. On line 6, we are invoking again. So this time we know that we can just copy and paste. And the return line number is line 8 again. Any questions? No? Okay. And what do we use this time to specify x? We use y, and y will be referring to column H, which has a value of 0. And then y itself is a local variable, always starts with something that is unknown. And then we continue on line 4. Line 4 still has to do what it is, what it has to do. y gets x minus 1, x is 0, so y gets negative 1 in this case. Then we move on to line 5, x is 0, 0 is greater than 0 is false. There's nothing to do here. We go to line 8. Line 8 has two things to do. When you get to the end of a subroutine, there are two things to do at least. One is, the first thing is to look up the return line number, the rightmost return line number. It tells us we have to continue execution on line 8. Now this part can be confusing because it seems like we're doing this, and that is correct. We are, in fact, going from line 8 back to line 8. After you know where to continue execution, these columns have no use anymore, so you just have to indicate that these columns are no longer allocated. If you use the convention that I use in the notes, which is using just exit out, that's fine too. You can just use that notation. It's just that here I'm going to use this notation. It'll use a bar to indicate the column is now free. Same thing happens here. We're on line 8 again, so we have to do the same thing to deallocate this time column F to column H after we understand that we have to continue on line 8. Oops, wrong place. There we go. Now we're back to line 8 again. So we have to do exactly the same thing, except this time we have to continue at post. Then we can destroy the 3 columns just like that. And we're done. Are there any questions? Any particular question about how we go from line 8 to line 8 back to line 8? No questions about that?
You don't ever have to go to end it. It's only
Sorry?
from ending and define sub, don't end it, never
There are no
never
arrays.
keep the end it from. Right?
It terminates only because line 5 is a conditional statement. So the recursion ends at some point as soon as x is no longer greater than 0, we don't invoke the function again inside the loop, and that stops it. Okay, so that's that, and I think I just saved it, so we are good to go here. All right. So let me just point out where. Oh, I just closed my browser, didn't I? All right. So let's go back and let me show you where we are at. Because the next topic is not. It will take a little bit more than what time the amount of time that we have today to finish. So we'll do some of it today, and then we'll do some of that on Thursday. And this one is called the return value. Okay, how to return a value from a subroutine. Yep, go ahead.
How many more homeworks are there, just out of curiosity?
How many do you want? 50. No, I have to do the grading. There'll be some more. I'll give you guys, like one more today, for passing by reference, and then there'll be another one at least for returning values. All right. So we are basically done with local variables and parameters because we have talked about passing by reference already. I went through a few traces with passing by reference. So now we are down to returning a value, but I do have to kind of emphasize that you should refer to the notes. Where is it? I thought there's one extra link. Oh, right here. I put it at the wrong place. Okay, never mind. I'll move it out from the wrong place. Now, what you also need to read is this part here, updated subroutine notes. Okay, it's an updated version of what we have talked about so far using a new notation, but it's the same stuff, same concepts, just explained differently. So now we are back to returning values from a subroutine, which means you are expected to read that stuff. If you have questions about it, bring it to the class. But in the class, I would use different examples to illustrate the concept. Okay, which is exactly what I'm doing now. I'm using a very simple example to illustrate the concept of returning a value. So let's go ahead and define a subroutine, and I'll define this subroutine as 5. Okay, define sub 5. And the only thing this subroutine does is something that we have not seen before. It has a statement called a return statement. And in the return statement, it returns the actual numeric value of 5. And define sub. In fact, let's not use 5 here because we all know what 5 is. So instead of 5, I'll say wu. Okay. I'm sorry, the Chinese people will definitely get confused because wu is 5 in Chinese, but the whole idea is to name the subroutine to something that relates to 5, but you guys do not know it yet. Okay? And the main program would be something like this: print, invoke, wu, and that's it. Now, this is the very first time we see something like this. We are putting an invocation of a subroutine inside something else. Okay? So we want to find out what this does. Now let me ask you another question. Let me ask you, do you know what this statement would do?
Display 5.
It just prints out the value of 5 to the screen, or the printer, whatever output device you choose, right? So we know what that one does. So the question is, what is this one going to do? It seems to me that the invocation of a subroutine is taking the place of an integer, or what we can expect an integer. Yes? Okay. Okay, let's change this one here. Let's change it to something that we are even more familiar with: assignment statements. Okay. We all understand what x gets 5 would do. Okay, it would be initialized to a value of 5. X gets 7 would get x initialized to a value of 7, because we know the right-hand side has to be some kind of a value that you can use to initialize the left-hand side with. So in this case, we know it seems like we're expecting the invocation to give us something back so that we can initialize, in this case, the global variable x. Okay, and that's exactly what it's going to do. The trace is a little bit awkward because I have thought about this for a long time, how to represent the concept of the return value in a trace, and the best I can come up with is what is in the notes already. And that's the notation that we are using today. And this time, we can magnify a little bit more. Okay. There's no comment here because we don't have any conditions to evaluate. We just have line number. And we do have one global variable x, so we have to say in the precondition x has no particular value, so it's unknown. Okay. That part should be easy. And the first line we execute is line 4 because that's the first line outside of the definition of any subroutine. On line 4, we have a little problem now, because remember what we used to do? We used to say return line number, and we would have said post. But that would give us some problem because that means after we finish with the subroutine wu, we'll go to post. We never get a chance to finish up what is left on line 4, because we have an assignment to do after the invocation. So this notation doesn't work anymore because we cannot just say which line we're going to. We have to say which line we're going to and what is left on that line to do. Okay, so this is you can see this as an extension of the concept that we have talked about so far, because not only are we remembering which line to go to, we're also remembering what else we have to do on that line. So instead of you calling that return line number, I just call it return info or return information. Tell me where I'm supposed to go back to, or what else I have to do after we go back. And the way we represent this one is we have to go back to line 4. But not only do we have to go back to line 4, we have to finish up the assignment operation. But what about the invocation itself? We use a question mark in this case to take the place of the invoke, because the invoke is going to give me a value that I can use later on to finish up the assignment operation. That's why we use this notation. The invoke that we are dealing with is replaced by a single question mark. It's a placeholder. Okay, so we'll see later on, how do we use the placeholder? How do we specify a value, with this placeholder representation? Okay, are we kind of doing okay so far? After we specify the return info, there's nothing else to do because we don't have any parameters and we don't have any local variables. So we go straight into the subroutine, which is on line 2, and we just run into another type of statement that we have not seen before, the return statement. The return statement does something. It does two things. Okay, you can look at it as two things procedurally speaking, but it's actually just one thing. All it does is to use the value of the return to replace the placeholder. That's all it does. Okay, but procedurally speaking, what we're going to do in this case is we'll copy and paste the return info cell, and then we just say, oh, we now know what the placeholder is supposed to be. It is supposed to be 5. Okay? So that means the invoke and the return are closely related. The invoke will give you a placeholder. The return will help you, will specify what value should go into the placeholder. Yep.
And then I guess later on, you could have a long thing inside a subroutine and it would return the final result.
Correct. That is absolutely correct. Okay, so now we can, line 2 is done. All line 2 does is to copy and paste the return info cell, change the question mark to the value that we are returning. In this case, I'm returning a constant. There's no calculation involved. And we are done. Now, you have to remember, at this point, we don't do anything with x. The return statement, in this case, does not do anything with x. All it does is to change the question mark to a value. Is that okay? Because that can be very confusing later on if this part is not clear. Then we go to line 3. Line 3, once again, doesn't do anything really that spectacular. We know that we have to go back to line 4 from the return info. We know that we have to go back to line 4. In fact, we know by the time we get back to line 4, this is what line 4 looks like at this point, because we already know what the right-hand side is. It is just the value of 5. After that, we do the usual thing. We just say that this column is no longer needed. It is now deallocated. Now we get back to line 4. But line 4 now looks like this. So we know exactly what else we have to do. We have to change the value of 5 of x to 5, and we're done. That is the return, the concept of invoking a subroutine that can specify a return value. Yep.
So what's the name of this algorithm again?
There's no algorithm. The concept is called returning a value, or just return value. Yep.
For this, what if you had return 5 and right after it return 10? Would it
That
only
is a
execute
very
the
good
first
question.
return?
That's a very good question. The question, let me just repeat the question to the class and also to the recording. The question is, what if we have return 5 and then we have a line 2.5 that says return 6 or 7 or whatever? Okay. The answer is it is somewhat language dependent. Go ahead.
I was just going to say, in this context, it would be overwritten.
In the context of C and most programming languages, the return will also automatically go to the end of the subroutine. In other words, when you execute a return, it will also, as a result of the return, it will also go to the end defined sub. Effectively, in the language of this class, it will effectively jump to the end of the subroutine and exit right away. But there are programming languages that will allow you to change the return value midstream, which means the return statement does not actually change, does not get back immediately. You actually have more chances to change the return value.
So if you wrote 2 returns on the final, which process would you use?
I think you should say that we do not know because we are not, because I did not because I do not specify is it C or Pascal or VB. So your answer should be saying you should just say it's language dependent. It's actually bad programming practice to have multiple returns in a subroutine, but people do it anyway.
Yeah.
Because sometimes it's handy. Yep.
Does the return have to be integer
You can have a comparison. It would just be returning a Boolean value. In fact, let's do that. So I will save this one, and we have enough time to go through another example. We'll just call this one simple return, and we'll go for another sample program. Okay. I call this is less than, and it will take two parameters, by x val, by val x, by val y, return x is less than y. Okay. So it's combining some of the concepts that we know already with the concept that we are introducing today. So in this case, I'll just use a print, and I'll say print invoke is less than, and then I specify 3 as parameter x, I specify 1 as parameter y. Okay, so this is a nice combination of things that we already know and things that we are just starting to introduce.
Return x is less than y, or return x is y?
Return x less than y as an expression. Okay, so we'll go ahead and take a look at what this program is going to do. Just need a little bit more. Here we go. Okay. We don't really have any conditional statement or loop, so we'll just start with a line number. There are no global variables in this case. The first line that is outside of the definition of a subroutine is line 6. That's what we're going to do. And because we know this is inside a print statement, we know that we have to go back to the same line to finish up some unfinished business. So we know that when we specify column B, we have to say this is return info because we have to go back to the same line. We're not always going to the next line. And the return info is going to be line 6 again. We have to finish up whatever the subroutine is returning. Is that okay? The question mark, once again, is a placeholder for the return value of the subroutine. Yep.
Do you need a comments column?
Nope, because there are no conditional statements.
X less than y.
But it doesn't alter the path of execution. I only use comments when the condition alters the execution path. You can have a comment line if you want to, but it's not required in this case. Okay, we have two parameters. We have parameter x, we have parameter y, and we already know these are by-value parameters, so they're just coming from the invoke statement. 3 goes to x and 1 goes to y as specified by the invoke statement. Now we are ready to go into the subroutine. The subroutine starts with line 4 because the other 3 lines really do not do anything at runtime. And line 4, okay, let's just focus on the right-hand side of the return statement. What exactly is it returning?
True or false?
It's returning a Boolean, a true or false. In this case, it's returning x is less than y. It's false. Okay, because x is 3, y is 1, 3 is less than y is false. So it's returning a value of false. It doesn't matter what it's returning, as long as it is a known value, we are good. So that means what we need to do here is to copy and paste the return info cell, change the question mark to the value that we are returning. Whether it's a real number, an integer, a fraction, or a Boolean, doesn't matter. Whatever it is, we return it. We use that to replace the question mark. But we do not print anything here. You're right. Okay, so you're referring to the print statement for comments. Because we need that column to indicate what we are printing later on. So you're right. We still need that. Okay, after line 4, we go to line 5. Line 5 has 2 things to do. One is to tell us that we have to continue execution on line 6. The second part is to get rid of the columns that we have allocated for this invocation. So we go to format, we go to cells, and change that part. Now we are back on line 6. But line 6 doesn't look like this anymore. Line 6 now looks more like this, because we already know what we are supposed to print, so we are now ready to print. So when we execute line 6, all it does is to print the value false on the screen, and we're done. There's nothing else to do. Okay. Are there any questions here? And as I said, right on time, because, So go back, when you go home, make sure you read the notes that is linked from Moodle, because that will give you, the information, the definitions, and also, and whatnot.